For those interested in learning Solana development, many get stuck on the various types of accounts before they even begin. It's hard to grasp why, when you have a single wallet address, there's a need for all these different types of addresses. If you're just a user, it's not too bad you only need to know what a wallet address is and what a token address is. But if you're a developer, what you need to understand is this. Today's lesson is crucial. If you don't get this, there's no way you'll be able to understand the various confusing logics and strange expressions in Solana programs. Simply put, interacting with Solana means interacting with different account addresses. You might think it's just a parameter or variable, but it's actually an account. You might think it's a program, but it's still an account. And when it comes to storing information, it's all about accounts. This is really important, and storing information is too. You could say that in Solana, everything is basically an account. And because different address types are separated, you won't see congestion piling up in one place. On either if there's ever a super popular project and everyone rushes for an airdrop, it can lead to network congestion. So, other types of transactions, like personal transfers, could also experience congestion because it's equivalent to, first of all, a wallet account, which is the easiest concept to understand. A wallet account is the user's main account, used to manage SOL tokens and interact with other accounts. Typically, we can automatically generate this address using wallets like Phantom, so that's not a big issue. Now, the second one is a bit trickier, the system account. A system account usually refers to an account created or managed by the system program. These accounts aren't much different from regular accounts. They can also be used to store specific data. Any newly created account is essentially a system account because it's initialized by the system program. Don't believe me? You can check it out on your blockchain explorer. Is the owner of your wallet account address the system program ID? If so, the account is a system account. In other words, both your wallet account and mine are managed by the system program. Now, the program account is easier to understand if you compare it to either. A program account address is basically the address of a smart contract. Oh, in Solana, it's more accurate to call it a program rather than just a program address. And they don't refer to it as an address, they call it a public key. The owner is the wallet address of the person who deployed the program, and they have the authority to upgrade the program. Also, a single smart contract program corresponds to a program account address. Program-derived address PDA is a concept that, in my opinion, once you understand it, you'll have a kind of aha moment. It's like suddenly grasping why the founder of Solana designed things this way. Let's start with how it's generated. Here's the basic principle. Don't worry if you can't fully grasp it yet. The idea is that a PDA is derived from the content you mix in called seeds plus the program address. As for how many seeds you mix in or what those seeds are, that's up to you. The result is a bunch of encrypted gibberish derived through SHA 256, and that gibberish is actually our PDA address. Essentially, it's a brand new address generated by mixing in some content you've specified as random seeds. And the best part is that your program has management authority over this address. You can use this address to store and transfer SOL, or even to store information. Alright, let's circle back to what we were discussing. Everything is an account, and we use accounts to store data. Let me give you an example. Suppose I want to record a wallet address linked to a username or a specific level. We can start by creating a data structure using a class, but this structure isn't active yet. You need to pass in a PDA generated from something like the username and the user's wallet address, and then have the system initialize and activate it on-chain. Now, why use a PDA? It's because this PDA acts like a unique identifier for the information you just provided. This identifier is essentially a bunch of gibberish and address, really, but it uniquely ties to the data you input. Let's not think of it as just an address, it's really an identifier. With this identifier, I can retrieve the corresponding data. For example, if I have a PDA generated from your name and your wallet address, I can use it to get your name. If I have a PDA generated from a level in my wallet address, I can use it to find my level. And for all sorts of other data, I can use this same method to record and access it. Exactly, the PDA is essentially an identifier for recording data. As long as we have this PDA, we can retrieve any data associated with it. But the key point is that this data must have been previously recorded or input. Now, let's circle back to the token account. The reason I skipped over it earlier is that the token account is indeed very similar to a PDA in many ways. So, how do we understand the token account? or the token account. You can think of a token account as a container for storing a specific address's tokens. Each token account is linked to a particular SPL token and keeps track of the balance of that token. These accounts are associated with an owner, usually the public key address of a user. The owner has the authority to control the transfer of these tokens. So, how do we create this token account? Actually, we can use the Solana Web3 JS library to create a token account. I get that it might be hard to wrap your head around. Why do we need to create a separate token account when we already have a wallet? It can be confusing, but let's take a look at the code to better understand how this works. This is for creating a token account. The libraries we're importing, like Solana Web3 and Solana SBL token, are the ones we'll need for the code. We'll dive into the details in a later lesson, but for now, let's take a look at the create token account function. The first step is to connect to Solana's mainnet. I'm not exactly sure why it's written this way, but that's okay, just focus on the logic. First, we connect to the mainnet, and then we generate a wallet key pair. But you can also input a key pair yourself, no worries there. Just make sure to enter your token's address, because creating a token account requires knowing the token's address. There's also a payer, which is the person covering the SOL transaction fees. Now, the last step is the most important part, creating the token account. This is done using the create account method from the SPL token library. You just need to fill in those 4 parameters, and you're good to go. The 4 parameters we just mentioned are connecting to the mainnet, who's paying the gas fees, the token's address, and finally, the owner's address. When you combine these 4 parameters, you generate the token account, which is basically the address for the token account we talked about earlier. This is your token account. Now, don't these 4 parameters kind of remind you of what we discussed with PDS? Right? You can think of them as seeds. Essentially, this token account is like a PDA, used to store the data related to your token, like how much you own or other information about the token. Let's expand on this a bit. So, now we have the token account, but how do we actually make a transaction? Because what we've done so far is just create the account, not perform a real transaction, it's only setting up the account. Alright, let me show you another piece of code. Here, we have a function named transfer token. So, the first part of the code is all about what we just discussed, combining those 4 parameters to create something similar to a PDA, which is essentially the token account address. Now, this TOKEN is actually the token account we just talked about. When you use the TOKEN transfer method, it takes 5 parameters. These parameters are: the first 2 parameters are the owner and the amount to be transferred. This method allows you to transfer or send SPL tokens using the transfer function. So, when you look at the code, you should be able to see that the token account we create is essentially an identifier for the relationship between a specific token address and a particular owner. If you understand it this way, it becomes much easier, right? As for the actual code execution and how to use these methods in detail, we'll cover that in future lessons. Don't worry if you don't fully grasp the code just yet, it's totally fine. The important thing is to understand the basic concept I just explained. Now, about the 6-point multi-sig accounts. There's not much to elaborate on here because Solana natively supports multi-sig accounts. Unlike Ethereum, where you need to rely on a third-party multi-sig smart contract, Solana has this functionality built in. This means that multiple signatures are required from different accounts to execute a transaction, which greatly enhances the security of the account. So, users can create a multi-sig account using the SBL token program CLI, which has a command for this. You can also use the SBL token library to do it. You just need to set it up with the required signers and their addresses. For example, if you have 4 people, you can configure it so that only 2 signatures are needed, or 3, or even all for whatever you decide. All 4 must sign before a transaction can be executed if that's how you set it up. You can set this up yourself. This is for creating a staking account. The staking account is used to stake SOL in order to support network security, participate in consensus, and earn rewards. It's similar to Ethereum's staking mechanism, where they switched from POW to POS, using staking for consensus validation. The method for creating a staking account is actually quite similar to creating a multi-sig account. You also use the SBL token program to create it. Since staking accounts are not used as frequently, I won't go into much detail here. If you need it in the future, you can always check the documentation for instructions. Alright, now for the 8th one. The temporary account. This is used to temporarily store data within a specific transaction or program. Once the data has served its purpose, the account doesn't retain it. The data is automatically destroyed. It's kind of like a variable or a field in a smart contract that holds some information temporarily while other functions need to use it. Once it's no longer needed, the stored content doesn't need to be kept on chain, but it needs to be stored temporarily to perform some calculations. As we know, all stored information in Solana requires an account. That's just how it works. So, creating a temporary account serves this purpose. How do you create it? It's actually done within the smart contract or program code, just like you would declare a variable. Now, moving on to the ninth one, the storage account. I'll speed this up a bit. As I mentioned before, all stored content in Solana requires an account. If I go into more coding details later, I'll explain this in more depth. The 10th type is the rent-exempt account, which is pretty interesting and worth diving into. All of our programs, tokens, and various account addresses, whether they're storing information or running programs like smart contracts, are subject to rent. This means they require a fee to keep them on the blockchain. However, there's a way around this, which is where the rent-exempt account comes in. To better understand how this works, you can actually check it out on the Blockchain Explorer. It clearly states how much you need to pay annually, usually calculated in Lamports, which is the smallest unit in Solana. If you don't pay the rent, your stored information or data could be destroyed. When you open the program account information in a Blockchain Explorer and scroll down to its creation hash, you'll see a section labeled RENT. This is where the rent-exempt status of the account is displayed. If an account is rent-exempt, it means it has a sufficient balance to avoid paying rent, ensuring that the data or program stored there won't be automatically deleted. We can click into check, and you'll see that the rent exemption is valid for 2 years. The rent is calculated in Lamports per byte per year. For example, if Solana's smallest unit is 9 decimal places, it might show something like 0.0 followed by 3,480 Lamports. So even if you need to store just a little SOL, it's still necessary to have some. As long as your SOL balance meets the rent exemption threshold, you can obtain the rent exemption status. That's it for this video. See you in the next one.